So accelerator mass spectrometry is an ultra-sensitive technique, and so that enables us to make measurements that you can't make any other way. So we can look at either old debris where that isotope has decayed away to the point that you can't make that measurement really any other way, or we can look at really trace unusual isotopes that just don't exist in high quantities. So with this AMS technology, we can look at those very, very trace signatures that really aren't accessible by any other method. So at CAMS, we do both pre-detonation and post-detonation nuclear forensics research. So for pre-detonation, we're looking at nuclear materials like uranium ore concentrates and things like that might have been interdicted. And we're trying to answer questions of where did that material come from, what was its intended use, and can we identify anything about that material? So uranium is a naturally occurring element and we mine it from the ground. And so in the ground, there are these ore bodies, which are just big ore deposits that you target for mining. And so when we find a uranium ore body, we can actually tell a lot about the formation of that ore body based on some of the signatures and isotope ratios that are present. And we'd like to investigate the uranium-236-238 isotope ratio as a pre-detonation forensic signature. And that's because 236 is formed based on neutron capture on uranium-235. So if we can understand that environment of the ore body, we can actually start to tease apart what controls the formation of uranium-236. And that's important because it means if we find a sample down the road and we measure that 236-238 ratio, that we can back calculate to find some information about that ore body. And that enables us to sort of eliminate potential suspects or origins of material that's been recovered or identify potential sources of that material. We have a new capability coming online with a gas-filled magnet. One of the reasons we're excited for the gas-filled magnet is it will enable us to get better separation between some of the transition metals. We're really interested in measuring transition metals for post-detonation nuclear forensic signatures, but the transition metals have a lot of overlap, and so there's often isobars that prevent us making really good measurements on an analyte of interest. And these transition metals can be really useful in post-detonation forensics because they can provide some information about structural materials that could have been found in that device.
The device you see standing behind me is what's known as a gas-filled magnet, and it's literally what the name says. It is a large dipole magnet into which we can bleed a small residual gas. Ions entering that gas will charge exchange, gain and lose charge depending on their atomic number. And so isotopes that have the same mass but a different atomic number will achieve a different mean charge state within the magnet. And because these ions are traveling through a magnetic field, they will be bent on a different radius of curvature. And this will allow us to filter out the unwanted isobars from the isotope of interest. The motivation for CAMS to develop a gas-filled magnet was really driven by the need to measure very specific isotopes for national security missions. These are the transition metals as well as isotopes like aluminum-26. These are isotopes that have specific and pervasive interferences that really the only way to do the measurement at the levels that we needed to was with a gas-filled magnet. I'm really excited about the gas-filled magnet coming online because of the wide range of measurements it will allow us to do that we currently can't. It spans the range from nuclear physics and astrophysics type measurements, national security, nuclear forensics type measurements, but also a host of isotopes that are relevant to cosmochemistry and earth sciences. At CAMS, we have a large user community that we make measurements for in the area of earth science and geology, and there are new isotopes that we will be able to measure to support that community.